Hi everybody, this is the video for the solutions for homework 9 on correlations. So number 1, so just like what we covered in the lecture, the first thing I would do is I would multiply x times y. X would be high school GPA here and y would be college GPA. Multiply those two and get the new column right here. Then sum for each of the columns. So you have the sum of x, high school graduation or high school GPA, sum of y, the college GPA, and the sum of xy. And then the final thing to do is to take the x's, these data, and enter it into the online calculator for sum of squares to get the sum of squares for x. And then take these data and put it into the online calculator and get the sum of squares for y. Now we have all the stuff that we need to calculate the correlation. So first step is to calculate the SP. Here's the formula. So we know the sum of xy is 116.14, sum of x is 34.48, sum of y 33.37 from above. So we just plug in the numbers. And so when we take the sum of xy, we multiply them and divide by n. N is 10 in this case. We get 115.06. So the SP that you should get is 1.08. And then we can calculate the correlation. And the correlation is simply that SP that we just calculated divided by the square root of the sum of squares x times sum of squares y. So from above, from the online calculator, here's our sum of squares x, sum of squares y. So we go ahead and we multiply these two things, and then we take that product and we take the square root. That should be 1.79, sorry about that. And now we can simply just calculate our R. So our R is SP divided by the square root of the sum of squares x times sum of squares y. So the correlation is 0.60. We have 8 degrees of freedom. Why 8 degrees of freedom? We have 10 people. And we have 2 variables, so we have to take 2 degrees of freedom off. So 10 minus 2 is 8. We go to our little table here. Remember, we do one tail, and we have 0.05. We have 8 degrees of freedom, so 0.549 is the critical value. 0.549 right here. Sorry about that. There's something wrong here. I'm going to correct this. We reject the HO because what we calculated is greater than the critical value. And the final bit of calculations is we want to get R squared. R squared is simply our correlation that we calculated multiplied by itself. 0.60 times 0.60 is 0.36. So remember that R squared is, the interpretation is that 36% of the variance in college GPA is directly linked to high school GPA. So here's our little sentence that we write. There is a significant positive correlation between high school and college GPA, comma, R equals 0.60, and comma, P is less than 0.05 because we rejected the HO. The R squared was 0.36. Remember, we don't need to say small, medium, and large here because people that know correlation research know that the R squared is the percent of variance in the Y directly linked to the X variable. So 36% of the college GPA is directly linked to the high school GPA. So let's do number 2. And so we have 10 employees. We have 2 measures here. And so just like before, we just simply, we want to take the X, dexterity, times Y, the productivity, to get the XY. So we do that for everybody. So we have a new column, a new variable here, X times Y. Right here, your number should look like that. Then you want to sum all 3 columns. So you have the sum of X, which is dexterity. You have the sum of Y, which is productivity. And then you have the sum of XY right here. And then we take these scores for dexterity, which is our x, put into our online calculator, and we can find the sum of squares. And then we can take the scores for the variable y, productivity, and put it in the sum of squares calculator, and we get this. So now we have all our numbers. So we take the formula for SP, we do SP first. We plug in the numbers, sum of x, y, sum of x, sum of y, divided by n. N is 10, there's 10 employees. When we solve for it, we get an SP of 274.7. Then we figure out the R. The R is the SP divided by the square root of the sum of squares x times the sum of squares y. So our SP is 274.7. Our sum of squares x is here. Sum of squares y is here. That's from the table above. We solve for that. We get 357.27. So we take SP divided by 357.27. We get a pretty big correlation here of 0.77. Our critical value is the same as the one above because we have 8 degrees of freedom. We have 10 employees, 10 people. We have 2 variables, so we have to take 2 degrees of freedom away. So 10 minus 2 is 8. So our calculated value is greater than the table value. Therefore, we reject the HO. The last thing we have to do is we have to do R squared. So R squared is simply the correlation times itself. So 0.77 times 0.77, we got 0.59 for our R squared. That means that 59% of the variance in productivity was directly linked to dexterity. Then we write up our little sentence here. So dexterity was significantly and positively correlated to job productivity. R equals 0.77, P less than 0.05 because we rejected the HO. R squared was 0.59. And then we do a simple regression for the data from question number 1. We already have all this information, so except for the means, but we can figure that out pretty easily. So we have the slope. The easiest way to figure it out once we've done a correlation is to take the SP, which we already have, divide it by the sum of squares x, which we already have. So from above, the SP was 1.08, the sum of squares x was 2.67. So to get the slope, we just divide those two numbers, and we get a slope of 0.41, which means for every 1 unit increase in high school GPA, there is a 0.41 increase in college GPA. So that's the slope. Then we can find the y-intercept, the A, by taking the mean of y minus the slope times the mean of x. So we can actually get this from above. So we have the sum of x is 34.48. There's 10 people, so we divide that by 10 to get the mean. The mean is then 3.448. Same thing for this. Divide the sum by 10, we get an average of 3.337. We take those things down here. Give me a second to get to the right spot. So here's our means, just what I said. So the mean of x, the mean of y, so we plug it into that formula. We solve for it. The y-intercept is 1.92. So now all we have to do is to express it in a linear equation. So y equals 0.41x plus 192. So what that means is if you know the value of x for a person, you can predict their y. So the x in this case is the high school GPA, and if you know their high school GPA, you can predict their college GPA. You simply would plug in their high school GPA into x and then solve for that to predict y. Then finally, question number 4. So it says take the data from number 2 and convert it into ranks. And so that's what I've done here. Here's the ranks that you should have the ranks for X, 1 through 10, ranks for productivity, 1 through 10, and then we take those rank scores and we just do the same thing that we did before for the Pearson correlation. So first step is you multiply those numbers for everybody to get X times Y. You add the 3 columns, so you add and you get the sum of X, the sum of Y. Notice the sum of X and the sum of Y are the same. Why? Because you have ranks 1 through 10 for both of them. They're going to add up to the same thing. Then you have the sum of the XYs. Put the numbers, these numbers, into the online calculator to find the sum of squares. The sum of squares for X and the sum of squares for Y should be the same. Why is that? Because you have the same numbers. You have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So let's go ahead and solve. So we figure out SP. We plug in the numbers from the table above. Plug in the sum of XY. We plug in the sum of X, sum of Y, and we divide it by 10. There's 10 people. We solve for that. The SP is 63.5. And now we can do the correlation. Correlation is SP divided by the square root of sum of squares X times sum of squares Y. So 63.5 was our SP. And then we take the square root of 82.5 times 82.5, which should be 82.5. Let me just quickly do that. Why not? 82.5. Whoops, that's not working. Sorry about that. My numbers lock wasn't on. 82.5 times 82.5. And take the square root, 82.5. And so you take 63 divided by 82.5, and I'm just going to do it real quickly. 63.5 divided by, whoops, yeah, that's right, divided by 82.5, 0.77. So our critical value is the same as we had above because we had 10 people. So we have 2 variables. We have to take 2 away. So 10 minus 2 is 8. So our critical value is 0.549. So our calculated correlation is greater than our, sorry about that, is greater than our table number. So we reject the HO. Last thing is to take the R squared. So taking 0.77 times 0.77, 0.59. So it's the same, I think, as what we had before. So 59% of the variance in productivity was directly linked to dexterity. But this case, it was an experiment. So we write it up. We say that the data from the study was converted to ordinal data using ranked order scores in order to do a Spearman correlation. There was a significant positive correlation between dexterity and job productivity. R equals 0.77, P is less than 0.05. R squared was 0.59. So those are the solutions to the homework. If you have any questions, please attend one of the Q&A sessions. So